Okay, so now we're going to move to methanol and methane, we're going to finish up the day with. And again, take a look at the difference. What's the difference between methanol and methane? One's polar, one's nonpolar. One's an alcohol, one's a gas. And the difference here is just that OH. If we have methane, we have the CH4, like so. And that's a tetrahedral molecule, very nonpolar. Methanol, on the other hand, has only one OH on the end of it, and that in itself makes it polar. And that's enough to make it a liquid. But it's also pretty small. And so because of that, there's not as much London dispersion forces working. It can actually vaporize very quickly. So here's your methanol, just as we would expect. It is a liquid at room temperature. However, it can vaporize very quickly, so this is something that we want to be careful with. In fact, when you hear about some lab accidents, there was actually just one in Minnesota, I want to say, not too long ago. It was basically due to methanol. And if you leave the cap off of this one, it can vaporize quickly, and this can actually cause some major problems there. So we do want to be a little bit more careful about that. Now, let's take a look at this one. Okay? I like to call this my whoosh tube, and you'll see why. We'll add a little bit of our methanol again. The methanol, more isn't always better, as we'll see here. So we just need a little bit. And we'll add about a capful. Okay. Now there's two things that I'm going to do here. First of all, by adding that, I'm going to first of all encourage it around the tube so it covers the inside of the tube. Now that's a surface area issue. If I have more surface area, I should have more faster chemical reaction. And secondly, it's also vaporizing a little bit too, so the reaction happens a little bit faster that way. So we should actually see this happen pretty easily now. We'll get ourselves a match. You want I should aim it at you? No, you're okay? All right, you sure? All right. Okay, so here we go. This should be nice and ready. Okay, now, I want you to watch this. So first of all, you're going to see two things coming out of the end. What should be coming out of the end? Well, you're not going to see carbon dioxide gas, but you will see, hopefully, water vapor. And there you go. So you see the water vapor coming out. And that's usually how we're going to see water vapor, is a type of condensation there. And that's, again, a sign that water vapor was coming out, just as we would predict from the combustion reaction. Now, what about CO2? Well, maybe we'll try this again and see what happens. I'm assuming there's still enough methanol in here that it won't be a problem. But this time, the chamber's filled with too much what? Yeah, it's filled with too much CO2, so the combustion stops before it even starts. So let's clean that out a little bit. This is all you have to do, just, you give it some air. Just got to walk my tube around. Like a javelin. Okay, so now this should be, for the most part, ready to go again. Let's check it out and see what happens. All right, we'll add some methanol to it again. I can clear out your sinuses real quickly if you want. Okay. All right. So here we go. Not as spectacular again, but one thing I want you to do, feel that. It's warm. Definitely warm? Yeah, you gotta participate here. There we go. Yeah, definitely you can feel the heat there. As we'd predict, we should have the light and the heat. The sound is an artifact of how the tube is shaped. So, the piece de resistance, the favorite of combustion day. Yes, this is why the ceiling is black. There's nothing like a little pot of bubbling methane bubbles. I mean, seriously. If you're not... Yeah, okay, so here we've got the methane. And again, this is the same thing that's coming out of the gas jets. So it's not like you haven't experienced methane before, but you haven't experienced it like this. So all this is dish soap. And I mean, I'm not too concerned that you're going to try this at home because, I mean, hey, you don't have methane at home. So what you have here, though, is the methane being captured by the bubbles. Pretty simple. So they're also lighter than air, so then they'll float. So you can do things like this with it. Nice. Yeah. We'll get it a little bit bigger. We'll wait till it looks like Marge Simpson this time. While I'm waiting, I'll see if we can't get that one going again. More. Yeah, that's fine. Okay, that more or less looks decent. All right. Let me try that one. Now, you're probably wondering, like, why doesn't the ceiling catch fire? Well, these ceiling tiles are not designed to burn easily. They still can be flammable, but they're not going to catch fire easily. What you see here is actually the soap residue. Like, I think that would be a fantastic detention assignment, is to go up there and scrub the soap off of my ceiling. But, yeah, and that's really what's happening is the soap bubble is again, a hydrocarbon. And what's happening is it's charring, basically. It's burning up. And that's the residue that we're seeing there. All right. No, you don't. No, you don't. Come on. Uh-oh. Oh. Wait. I can fix that. I can fix that. I can fix.
Just later. Yeah, right on the page.
Out of the way. There we go. There we go. Oh, what are you doing there? When there's too much soap, you can see the bubbles aren't as big. It becomes less dense than air, then actually sinks. Except for that one. So we'll fix you. And there we go. Yeah. Let's see if our jug is ready here. We'll just let it go for a sec. Okay, we'll try it again. That one was a little bit better. Yeah. But again, I think there's too much oxygen in there. And back to the bubbles. First hour, it went up and then it came back down and it lit the pot on fire. You had to be there. Like that. Yeah. That was staged. It wasn't as cool though. We'll let her burn out.
Yeah.